Hey everybody, Tony DeMakis with Alliance Specialties in Laser Sales and the Manufacturing Alliance.
I'm Justine with the TMA Education Foundation.
And we are here at HEIDENHAIN. They are the experts in CNC motion control and just motion control in general. This is an amazing facility.
Yes, there are so many innovation labs, so many training centers. This company is the leader in trying to just group everyone together and truly impact and change the world. So we're in the North American headquarters. They have companies in Sweden, Germany, and California as well.
So, we want to thank you for watching us. Stay tuned and see what this is all about. How does somebody get started in manufacturing?
Mm-hmm. Well, I would say, first of all, you have an interest to use your hands. You like to work on something, put something together.
I knew that I needed a lot of training to get on these, but HEIDENHAIN had that for me. And I've been trained by many rounds of German guys that have come over here, younger than me at the time, still younger than me. And so it just made for a great relationship. If you listen to what they tell you, like, they'll give you everything. You just need to do what they tell you and trust the process. And I trusted it. And, you know, I've worked hard to run these machines, like, safely. Like, I didn't work in a shop at 18. Like, I went to college. So, you know, I'm like your typical, like, oh, I was just going to go to college, but I didn't know what I was going to do with my degree.
They're students, right? And they're like, I don't know what I want to do with my life.
Yeah.
I've graduated high school. I don't know if I want to go to college.
Sure.
I don't know. Do they have to have all the answers coming in?
No, and I think that's not unique to HEIDENHAIN or to manufacturing. I think a lot of young professionals are unsure, right? I can think of myself as a college junior, undecided, right, of what I'm supposed to know, what I'm supposed to do for the rest of my life, right? And I think, from my perspective at least, I think it's good for potential employees or candidates to kind of have an idea of what their passion is or where their skill set lies, and then to just sort of develop from that perspective.
Perhaps getting into an apprentice program is really good, or a lot of times from companies that what they think are targeting is people with really good attitude more than like your skill set, and a lot of that can be taught. Like, so a lot of things on here can be taught if that individual is willing and wants to learn. So, you know, if you want to learn something, you'll make time for it. And me, I had just put a lot of time in order to run these machines. So, you know, you just have to be willing and have a passion for that. Like, if you have a passion for that, that will come across like in the interview, and you'll be given a shot. And then throughout your time there, if you are continually working at it, like, it's not going to go unnoticed.
Specific to HEIDENHAIN, I'm not sure that we're necessarily always looking for a very specific skill set, but I think we also recruit for kind of personality and kind of passion. So it's not necessarily, oh, like, you have this degree, so therefore you're going to be great here. I think we've learned in kind of, you know, experiences, maybe not the best hires aren't always, you know, the best hires are not always the best people on paper. I think many times you find that somebody maybe that doesn't interview really well ends up being the best employee that you have.
Yeah. What are those skills? What are those intangible things that make you think that this is going to be a good employee for the company?
I think it's the aptitude, right? They should. We can teach them a lot of things, but they need to have the right attitude about work. They want to be here. They want to learn. They don't want to stand still. They want to learn new things. They want to exposed and be challenged by our customers to say, hey, I have this problem. Solve that for me. And you need to be open-minded and say, well, it's not in my book and I don't know how to use it. You got to figure out a way to do it, right? That's not the answer. You need to be somebody who tries to solve problems.
When you first started, you didn't know everything you do now.
Oh,
so
no,
it takes time, it takes character, it just takes hard work, and this can be so intimidating to
Oh
a
my
high
gosh.
schooler. They're
Oh,
walking
yeah.
in, a college student, oh my gosh, I could never do that. They look at you, they're like, whatever Joe's doing, I could never do. But you're like, I didn't know I could do it
I didn't know I
either.
could do it either.
Yeah.
And I like literally just started like doing very simple things on these machines, and I just built it up. I made very simple tool paths, and I just did the basics. The little examples that I worked on were not groundbreaking, but it's because I didn't know what these systems could do. So like, you know, my brain is trying to organize how accurate this thing really is, and like how do people use this thing, and how do they program it, and why do they program it the way they do. You just have to start somewhere.
There's a lot of knowledge on YouTube. You see a lot of things about people making stuff with 3D printers, with machining parts. It's becoming really cool now to have a machined aluminum piece of something. And I think when you're really intrigued about that and you want to know more about it, I think that's a good start for you to go into it. But don't go in half-hearted, right? Go in there and really go in with all you can do. Everything about, hey, how does it work? Let me understand it. So you really have a good foundation to build up on that. This is what we call the Connect-In. This is a Connect Manufacturing Innovation Hub. So what the Manufacturing Innovation Hub is going to be, what we're doing on the West Coast, I should say, we're working with the associations together, AMT, A3, and others, the Semicon Association, to be partner of that. And the idea is to bring technology into the center, what is not necessarily Heidenhain technology, but it's manufacturing innovation technology. So let's say your welding products or whatever, right? Yeah. There could be something what you maybe want to feature, and we want to bring schools in, like Harper College, I'm reaching out to them, or even like smaller shops who want to go more into other technology, right? So we're setting up, for example, here we have an ABB robot. That ABB robot is going to be, it's actually a cobot. What will open up a fairly simple CNC lathe, putting parts in and out, right? It's very simple, easy solution, and you don't have to invest too much to do that. So we're going to have other equipment going to be in here. It could be water jets like we have on the West Coast. We have water jets. We have stuff about the semiconductor world. We have additive manufacturing in there. And we want to do the same thing here. So since we're in here, this is one of the products we're making here in this building. It's the Acrite Solutions CNC. So this is for the turning machine. It's a simple CNC turning machine. And people can basically upgrade this or get this with a Heidenhain, in this case an Acrite Solutions CNC. Inside the Acrite solution is Heidenhain technology. So we're using the Heidenhain power inside to build for the US market a specific interface. So it's a little bit simpler. So you have easy buttons, you have a conversational programming language where you can basically learn fairly easy, even if you don't maybe speak English too much. I wouldn't call it the sign language, but with the buttons here would explain, there's a turning tool. You want to do a radius, you want to program a radius, you want to program a line. It's very
more
easy.
Universal.
More universal. This is what I was referring to on the milling side. So if you have a smaller job shop, and a lot of people know this brand, right? Bridgeport is something, what is an old established US brand name. So for example, somebody has a Bridgeport machine in the shop, or some of the schools have these knee mills, right? The problem with the knee mills is that they usually just work manually, right? So you have to look at the dial here, you move the axes, and then you machine your part, right? So what people can do, you can come to us, and we sell them basically these solutions. So this is a motor, what is connected to a ball screw. And then you see here these linear scales. So that's basically a scale, what is mounted on the y-axis in this case. So this is the x-axis, and this is the z-axis. So we mount that on there. So now I can basically drive these axes because these motors are connected to the CNC control. And I can easily program these hole patterns. I can look at the tools, what cutting tools I have, what is the diameter. So it always asks me questions, so I have an interaction. How long is the tool? What's the diameter of the tool? What's the radius? Is it millimeters or is it an inch? So it's really, I can look at the entire tool table. So if I have multiple tools in here, my tool crib, for example, even though I have to manually load those tools in there, but I can do all that, right? So now I can use this machine still in a school or at your training facility as a manual machine because I'm just getting, so here you can see now I can use it as a manual machine, right? So as an apprentice program, if somebody wants to learn, or at a school, to learn manually first, so you don't give him the CNC capability, so he understands the basics, and then you teach him about, okay, now you want to do these hole patterns, now you can program that here, and you don't have to do that manually, right? You can also load DXF files into this, so you don't even have to program some of these. Sometimes you have dimension positions, right? You can just load that in there, and that works pretty well.
DXF step files too, or just DXF?
On this is only DXF. Yeah, on the HEIDENHAIN we can go step files, and 3D models and stuff like that. Okay, so that's a little bit about what we make here. And like I said, this is like an upgrade solution for Acrate. We offer that also on bed mills. There's a couple older machines, what are basically refurbished and so forth. So.
The need for manufacturing, what does that look like to you here in the US right now? Does it seem like an industry that's growing or an industry that's falling away?
I think it's an industry what is changing.
Okay.
I think people don't realize that this industry is very sophisticated and has to be sophisticated. The only way to compete in the global marketplace, not only with US competitors, but also with Asian competitors, other markets what maybe have cheap labor, we have to think about how can we apply new technology to make things more efficient, like 5-axis machining we talked about today. How you learn about automation, how you learn about monitoring your machine, how you're learning about using a digital twin to simulate, maybe like you do your race car on your Xbox, right? You're simulating a machine, what cuts apart, what maybe has to be manufactured in order to be ready when the machine is ready to put this part into machine it so you don't waste any time. So you stay price competitive. So there's a lot of opportunities, and people shouldn't be afraid of automation, right? Everybody talks about the robots are going to take things away from us, right? But if you do a job where you take a part out, you put a part in, that's going to be not a job you want to do, right? You rather want to have maybe 3 machines and you want to have a robot do that job for you, right? And you need to learn how that robot can interact. And on the HEIDENHAIN side, actually, we made it easy now, so you don't have to learn the robot control anymore. You can learn the HEIDENHAIN TNC control, and that control now control that robot.
Right.
So it makes it easier even, right? So things are gonna evolve and becoming really exciting, I think.
So what they do is you take students or you take young people who are curious, who want to learn how to do things, and instead of giving them a boring, monotonous job of pick and place, that's something that a robot can be programmed to do. Now what we need is we need the person that can think and program that robot and then run that cell.
There's a few companies out there in North America that are taking the people from high school and then putting them into their training program, and they have different avenues. So they'll have like PLC expert, they'll have like CNC programmer, they'll have manufacturing engineer, and they will build up the skill sets for each one of those over the course of 6 months, and then they will allow that person to then go into that job. And then providing that they do a good job, like they get hired and then they can work there. So they don't even have to go to a 4-year college degree. They can go to the technical, they can go through the technical school from that equipment manufacturer, from that end user.
I think a lot of businesses now will even say, like, we'll help put you through that trade school if you're the right person, if you have that curiosity and that
And
passion
HEIDENHAIN is
for
one
what
of
we're
those
doing.
companies, certainly.
So you guys do that also?
Mm-hmm. Yeah, we definitely have a tuition assistance program that we just revised in the last couple of years. So certainly that's an opportunity, not only for our maybe non-traditional younger professionals, but also for our whole employee base for continuing education. So that's something certainly that we promote pretty heavily here.
I think what's really encouraging is all the barriers to entry that people could say there are, the walls are coming down.
Definitely.
So
I would
whether
agree
it's,
with that.
I'm unprepared, cool, go to trade school.
Right.
I can't afford it, cool, we'll pay for it.
Right.
I don't have a school set, cool, we'll teach you.
Right.
And so when people get locked into this area of I need to do this first, all you really need to do is apply yourself.
Because there's so many opportunities now. Think about it. The baby boomers like me, they're gonna leave this industry in a couple of years. Maybe 5, 6, 7 years, depending how old they are. But there is a big gap, and we need people in manufacturing to follow that. So think about how big are the opportunities to get into these positions of being either an expert in manufacturing, machining, programming, running a machine, running a shop, maybe start your own shop eventually, because if you have all that knowledge and foundation, you may be able to start your own business and become into that. So there's a lots of opportunity, many more opportunities again to get a normal, simple degree at college. Just don't go to college and get a liberal arts degree and think you're gonna make tons of money. You maybe get lucky, but maybe you're ending up at Starbucks and you have $100,000 you gotta pay off. In manufacturing, you're making money the first day you're gonna go into the shop, and you're gonna pay your bills, and you maybe drive a car, and you have an apartment, and so forth, right? So you're starting on a completely different level. So take advantage of that, and I think there's opportunity to grow, and there's so many more manufacturing companies who are gonna come up in the United States, from semiconductors to people who build cranes and other things we need here. So opportunities are there, go for it. Everybody knows Heidenhain, right? And not everybody. A lot of people know Heidenhain. But what a lot of people don't know is that Heidenhain is basically a group. So if you think about an umbrella, right? The Heidenhain brand makes Heidenhain products with the Heidenhain brand on it. But underneath that, we have another family of brands. Companies Heidenhain acquired over many years and bought, right? And one of them is Accurate Solutions, what I keep talking about, the guys,
Okay.
the stuff we're making here. But all this other stuff, you probably never heard of, like LTN, for example, Numeric Jena. Those are very specific products, what are similar to what Heidenhain does, but in a very specific market. So for example, Numeric Jena, they make very small reader devices. So as you can see here, these are linear glass or linear scales. Okay. Some of them are glass, some of them are not. And then these are the reader heads. So they basically glide along this, and then you can basically measure the position. So since we talk about precision, Heidenhain equipment is also used in the semiconductor business. Like if you ever heard of ASML, those are the very high-end chip machine producers, right? So they make machine tool, or they make machines to make microchips and other electronic equipment. And everybody talks about AI, so I'll give you a little history about this. So if you look at AI, and you probably heard this, right? So if I Google something right now, I use a certain amount of energy with my computer. If I use AI for the same search, I'm gonna use 16 times more energy because I'm using AI. So that's why we get all these data centers and powerhouses, and Microsoft is buying nuclear power plants to power all that stuff, right? So that's the background of this. In order to bring the energy consumption down, what you have to do, you have to condense the chips, your microchips. So every chip has a layer and has a micro pattern in there, what basically has a circuit to work on the data, right? So what you're doing now, you can only do so many layers until you have to take another chip, and another chip takes, again, more energy. So what they're working on now is a layer for these circuits is about, if you have a chip in a car or something simple, you're looking probably at 60 nanometers. as a layer. Okay. So now, when we go with chips that are more condensed to can do more AI, the layers have to be coming closer together. And we're talking about now between 4 and 6 nanometer spacing, right? So if you want to now position nanometers, you have to measure in picometers. So do you know what a picometer is?
What's the thickness of a human hair?
Okay, I'm gonna explain that yet. So a picometer is 80,000 times of your human hair. So this is a fraction, right? 80,000 smaller than the human hair. So you need to position with a picometer in order to create a nanometer layer, right? So and that's where Heidenhain comes in, because we're making these measuring devices, what we call linear scales, glass scales and other encoder technology, it's also called, to enable these manufacturers to create this type of precision, right? Wow. So that's where Heidenhain is. So we're working on the nanometer side and picometer side when it comes to semiconductor applications, but we're also going all the way over machine tools, all the way to like a windmill, for example, right? So if you have a blade on your windmill, that has to be also turned based on how the wind is coming north, south, east, southwest, the wind's turning, right? You want to make sure that the turbine works all the time. So you need to change the blade. Or you want to take the blade out of the wind because you have enough power, or the wind is too strong so you don't have that thing falling over. So another company Heidenhain owns is Line & Linde. This company is up in Sweden, and they're making these very robust encoders. So you're measuring actually the angle. So it sits like this. Picture the blade sitting like that, and it's turning. We can measure now the angle because this thing rotates inside, and we measure exactly where the angle is. So you can program that. Obviously, that's connected to your programming system or your tablet or whatever they use to do that, right? So that's a heavy-duty stuff. You also find this in steel mills, paper mills, where you have a really dirty environment. And here's one cut open, so you can look inside a little bit, where you can see here's the glass, and then you have the graduation on there, and then we basically can measure the position, right? And it's very concealed, so even if it's dirty, salt water, some of these windmills are obviously in the ocean, it's all contained, it's safe, right? So we do that. So we're going from the nanometer up here, it probably doesn't really matter. If you're off by a couple of degrees, nobody cares, right? Then over here we have the Heidenhain technology, where we have what we call the encoder technology. So there's rotary encoders. It's similar to what you see there, but this is more used in machine tool environments. It's also sealed, but the accuracy is much, much higher, right? So here we're talking, whatever, a couple seconds of a degree in accuracy, right? And when it comes to linear movement, so if I move just an axis, X, Y, and Z, we usually, on high-end machining centers, you will find Heidenhain glass scales. And since they are in a dirty environment, usually because you deal with coolant, you deal with dust, what we do, we basically put them into these aluminum extrusion frames, right? And then you have, everything is sealed here, but inside there, you also find a Heidenhain scale. One of those glass scales I just showed you, right? And then this is basically mounted on the table or on the z-axis, and then this is moving and then measures exactly the position within micrometers for high-end 5-axis, 3-axis applications. So that's the linear scales, and then there's another company what is called ETEL. So ETEL is very heavily involved in this nanometer technology, picometer technology I was talking about. So they're making stages for the semiconductor industry. And they're out of Switzerland. It's also a Heidenhain company. But in addition to that, they're also making torque motors. So this is basically, if you look at, these are magnets. They're going inside here. There's a water coolant jacket on this, so because you get heat in that motor, and we cooling that motor. And usually a motor like that, it's either sits on a very big axis or it sits in the rotary table, and I'll show you that later on a machine. So ETEL makes that stuff for the machine tool world, but also linear motor technology. So if you want to accelerate and decelerate very fast, a linear motor is faster than a ball screw. So that's an ETEL product as well. Wow. And then last but not least is this. So this is a little example of also encoder technology. So if you look at this, there's a little graduation on there. It's hard to see, but there is, believe me. And then you have a reader head, what sits on here like that. That's got to be mounted, right? So where do we use this? This is something, if you ever heard about a telescope, the Keck telescope, right? In Hawaii, so they're looking into space. So if you think about this antenna, if you want to identify something in space, if your position down here is off by a couple degrees, up there you might be off by a mile or two, right? Yeah, wow. Exactly. So that's why these telescopes are getting retrofitted with this technology now, so they can measure position much more accurate when they do that. So HEIDENHAIN probably owns 99% of that market. Wow. So pretty much every telescope around the world is using HEIDENHAIN technology for positioning accuracy. Incredible. Yeah. So we go from the microchips all the way to the world, right? Yeah.
I know I get to do all the hiring at Alliance, and people come in with their cover letter or their resume, and a lot of times those are the least important parts of the discussion.
Absolutely, definitely.
So when you, when there's students coming in for their first interview, what should they be focusing on?
I think less focus on kind of that technical pieces that are so historically told that's what they need, right? And really just letting their personality shine through. I personally appreciate somebody that has like a good story, right? So I think I'd work really hard in interviews to put people at ease and try to get to the real person and kind of get rid of that fluff part of the interview, right?
That first date part.
Exactly,
where
right?
Everybody's on their best behavior,
yeah, right. And then you get
they're fake.
Yeah, exactly. So that would be my advice to a student, is to kind of be themselves. And, you know, also I think it goes a long way to do some research and kind of know who you're speaking to. There's nothing more kind of disappointing than when you interview somebody and they're like, oh yeah, I think I applied to this position. Where are you? You know, so I think kind of putting your best foot forward and being kind of thoughtful, I think, in what positions you're applying to, and kind of knowing who you're speaking to, I think goes a long way as well. I'm also a big fan of the thank you at the end of an interview, whether that's, I mean, I think a handwritten card is a bit much at this point, but a nice email to thank somebody, I think still goes a long way from my perspective, at least.
Well, because that's what you're anticipating you're going to get for their career, right? Not just their response to get the job, but for their career.
Exactly.
Right? If somebody knows who they are and who you are and what the company is coming in, it gives you a little bit of an idea that they may be a good employee that does their research, that puts in the extra time, that's not just trying to have a quick job, get paid, and go home.
Right, exactly.
They want to add some value
right.
to what the company is.
Yeah.
And that saying thank you goes a long way in any part of your day. I mean,
I agree, and I think that
be
also
a good human.
Well, I also think that goes the other way, right? I think saying thank you to our employees also goes a long way. I think when you talk about like total rewards, I think many times people assume that people only want more money or a raise or a bonus, and I'm a big proponent of small thank yous and letting people know that they're appreciated. So I think it kind of goes both ways.
Yeah, and that's what both people want, right? Like nobody wants to work for a place that doesn't appreciate them.
Exactly.
And no business wants to hire people that doesn't appreciate the opportunity and what's going on.
Right.
I want you to look at Jack, and I want you to tell the students that are watching this what they should be doing, where they should go next, and how they can find success in their career path.
Well, first of all, go to school, learn about math. I think that's important. You need to understand
Math. Do math.
Do math. That's very important. Understand a little bit about materials. What is plastic? What is aluminum? What is steel? What is titanium? Those are things. Then learn what is cutting tools. What is welding maybe? What is laser engraving? What is 3D printing? Metal printing versus polymer 3D printing. So look at all these different technologies and then think about what interests you most. Is it programming? Is it designing of parts? And then find either a shop or find an association, a school, where you can take classes to get a little bit better idea, and then find a good employer who looks for people. I started in mold and die application. I did my apprentice program. It was very helpful, similar what you can get at TMA. I think that's the first way to go into. Maybe look at an association, look at what people offer, maybe get into a shop as an apprentice or an intern to see what things are about manufacturing.
Saying our doors are open, we're hiring the right person. You don't
Right.
have to have all the answers.
Right.
We'll help train you. Just be the person and show up.
Exactly.
Cool.
You got this? You
Yeah.
ready? Ready?
Yeah.
I'm like starting this.
One and done. Yeah, I feel like you want me to start then.
Alright.
Are you saying, and I'm saying, I'm Justine with that TMA education.
Sure.
So you say, I'm Tony, and then I'll go like that, and then you go back.
Got it.
Okay.
We should do this more often.
Yeah.
Are we recording?
Yeah.
Wow!
Yeah.
There's the B-roll that we were looking for.
Going for 2 minutes.
All right, you ready?